Good evening, everybody, and welcome to the special presentation of the Denver Museum of Nature and Science. Thank you for joining us tonight for Beyond Bizarre, the crazy beast of Madagascar. I'd like to welcome you both to our webinar and to our Facebook Live event. So hello to both audiences. We're so glad that you have found a way to interact with us this evening. The best way to interact with us is down in the chat, so let us know where you're watching from and who you are watching with. We are glad that you are here tonight. My name is Alyssa Carlson, and I am a program specialist at the Denver Museum of Nature and Science, and I am pleased to host this webinar. I am very excited that everyone is here, and I will be managing the logistics tonight. So tonight we are discussing one of the craziest finds, maybe the craziest find, down in Madagascar, and we are visiting with our paleontologist and our curator of paleontology, Dr. David Krause. And if you guys will be patient with me for just 1 minute, it looks like we are missing one of our panelists. So give us just 1 minute and we will get that sorted out. But go ahead, fill up that chat. Let us know where you're watching from, who you're watching with, what you're super excited for this evening. All right, I found our panelist and she will be joining in just a minute, which is great. All right. So again, please let us know where you're watching from in the chat. Let us know who you're watching with. And we are excited to be here with you this evening. As I said, my name is Alyssa Carlson. I'm a program specialist at the museum. We are excited to host a Q&A with Dr. Krause at the end of this event. So if you have any questions during the presentation, throw those in the chat. We will try very hard to answer as many of those questions as possible. And I see that Gabby has joined us, so I am going to turn it over to Gabby, our Vice President of Research and Collections at the Denver Museum of Nature and Science. Thank you again for joining us, and Gabby, take it away.
Thank you, Eliza. This is just such a thrill. I've been seeing, all of the hundreds of participants that are joining us tonight. This is super exciting, especially because, first of all, like Eliza said, I'm the Vice President of the Science Division, but I'm also the Chief Curator at the Denver Museum of Nature and Science. I want to thank you all for participating from all over the country. I see coming in. And, we're super excited because, it's just been, very difficult for all of us this time. But when we see members like you joining us from all over and, supporting our plans and our project, it makes us really special, and we really feel thrilled that, we're doing this for you. And tonight, we have an incredible surprise for you. And I was super honored that I was asked to introduce our speaker tonight. And I have to tell you a little story. Don't panic, I'm gonna be short, I promise you. But dear Dave, who many of you know, sent me his 49-page CV when he heard that I was introducing him. And, we got to love Dave. He's just incredible. But I'm going to spare you the 49 pages because I'm sure you can Google him and you will find even more accomplishments from more than that, 49 pages. Dave is our senior curator of vertebrate paleontology here at the Denver Museum of Nature and Science. Dave joined us back in the spring of 2016 when he retired from Stony Brook University with, he's currently now Emeritus Distinguished Service Professor. So we're just thrilled that he decided to make Denver, actually Conifer, Colorado, his home, but that he decided to join the museum and his expertise. And, he really doesn't need introduction. So I'm gonna spare you his CV, but I wanted to share with you some really cool stories that I have heard through the 2 years that I have had the pleasure of working with Dave. And, his career spans, gosh, I'm not even gonna say Dave, but I was really impressed to see, and I can tell you that, you know, the first publication that he did was in 1977, and he has continuously published every year since then until today, until last week when you saw, you know, this amazing paper from Nature, which is, you know, a testament to his whole career that he's done, you know, in Madagascar. And another amazing fact about Dave is there are very few people that can say that, you know, they are fossils named after him. I actually have a fossil named after me, Dave, but you win the lottery here because he has about 10 fossil mammals that have his name. So I'm sure all of those of you that study, you know, vertebrate paleontology has probably pronounced some of the fossils that have Dave's name. Dave has done research field work in Canada, in the United States, in Pakistan, in India, and of course in Madagascar. And he, you know, he has really, I can probably tell you that his career has focused on, you know, is divided kind of like in three phases. When he first started his career, he started to work on the multi-tuberculate mammals from the Crazy Mountains basin of Montana. And then he moved into the Mahagangas Basin project in Madagascar, where he started back in 1993, and he currently works there. And then for us, when he joined the museum, he continues to work in Madagascar, but he's also joined our project. You probably remember our discovery last fall in the Colorado Springs. So Dave has, you know, a very distinguished career. He is beloved not only by the museum staff and the museum scientists, but is beloved by the professional community in this country and international. Because he's, you know, he's one of those persons that he does field work. He involves the local universities and the local students. So he has great associations. He had a distinguished award or a doctorate from the university in Madagascar, the Antananarivo. But he's, you know, he's also a great humanitarian. And when I met Dave, I was totally blown away by, you know, his humanitarian work in Madagascar, where, you know, he created a fund called the Madagascar Ankizy Fund. Probably I'm not pronouncing it correct, but Ankizy means children in Madagascar. And, you know, and through that year, you know, he's done work, but he's also giving back to the local communities where he works. So he has helped improve tremendously the lives of people in the rural areas in Madagascar. And of course, you know, inspiring so many of us by his work. They built the schools there, very involved in the health and dental care of a lot of these communities. And here back in you know, in the United States, Dave and his wife, Sue, have raised many generations, dozens of service dogs over the past few decades. He still has a golden retriever. He and his wife, Sue, like they live in Conifer. And so they love birding and they love going up in the mountains. And he's just, you know, he's an avid soccer fan. He loves soccer fan. And I was going to have an analogy, but I'm not going to do the analogy because he's just, he will tell you more about, you know, his different interests. But he's a great family man. He coached his son's soccer teams. And he is somebody that, you know, we love having in our team in the museum. And I know many of you that, you know, are joining us tonight from all over the country will join with me in Welcome Day tonight to present his work on Madagascar. Thank you, Dave.
Thank you, Gabby. Can everybody hear me, Alyssa? Am I on the screen? Okay.
Yes, it looks like you have a little thing blocking half of your screen, but we can hear you great.
Okay, let me move that. Great. Everything good?
That looks great.
Okay. So thanks very much, Gabby. Hi, I'm blushing with that introduction. Hello, everyone. So glad you could join us. I hope you're ready for a bit of non-COVID-19 news and information. Well, get ready because this is going to be a bizarre presentation in at least a couple of ways. First of all, it's about a bizarre fossil mammal, arguably the biggest discovery of my career. But secondly, it's quite frankly bizarre to be giving a formal presentation to an unseen, unheard audience of what I understand to be about 1,500 people. Thanks so much for your interest and for signing up. I'm sitting here in my home office over 3 months out from a haircut and inadvertently working on a ponytail and outfitted in a nice shirt and sweatpants. This is just plain weird. But let's get to it as I attempt to share my screen. Alyssa, you're going to have to tell me if that's working or not.
It's loading. Coming up very soon.
I might preface, therefore, if it's not loaded yet, I hope it is, because otherwise I don't know what we're going to do. We've had some glitches. And one thing we know already is that since I live up in the mountains of Colorado, my internet speed is not what it needs to be. So there'll be a little bit of a delay between what I'm actually saying and what you're seeing. So forgive us for that. There's nothing else we can do about it.
It looks great. You're off to the
Okay,
races.
okay, good. So we're ready to go. So this is a story of discovery, persistence, and frankly, pure luck, a journey that began indirectly in 1895, 125 years ago, and directly for me in 1993, 27 years ago. And it culminated last week. Hopefully you're seeing the next screen. And it culminated a week ago today by publication in the journal Nature of our discovery of a 66 million-year-old mammal skeleton from Madagascar, the so-called crazy beast. This nickname is encapsulated in its formal generic name, Adalatherium, which literally means crazy beast in a combination of Malagasy and Greek words. This is also a story of collaboration. To study this important fossil, I invited some of the leading experts in the world to participate. And this includes paleontologists and geologists of 6 different nationalities from 6 different continents, and actually from 11 different institutions. So let's backtrack a little bit and say a few words about Madagascar, just to get everyone oriented. So Madagascar is an island off the southeast coast of Africa, and it looks like a fairly small island, but relative to Africa, pardon me while I'm turning off my phone, another technical difficulty. So people have the perception that it is a pretty small island. But if we overprint it on a map of the United States, we can see that it's actually a very large island. And hopefully you're seeing a red Madagascar expanding on the map of the United States. And you can see that it's over twice the size in area than Colorado. And if it were a state, it would be number 3 behind Alaska and Texas. And Madagascar is host to a phenomenal biota, both plants and animals. And this just gives you a sampling of the diversity of plant life. And here's an animation coming in that might be slow to load, but it basically says that there's over 12,000 species of plants. Estimates vary a lot. Over 80% of which are found absolutely nowhere else in the world. And this pattern of uniqueness, this pattern of endemicity, is seen throughout the animal world as well, whether you're talking about insects or spiders or snails or mammals or birds. There's a high level of endemicity, uniqueness in the fauna of Madagascar. And that also applies to the living backboned animals of Madagascar. And here again, I'm just showing a sampling of them. And you can see perhaps right here if my pointer is following. Arguably the smallest reptile in the world, but of course the signature group of vertebrate animals in Madagascar are the lemurs. And here's an important piece of trivia, which is that 99% of the species of terrestrial backboned animals, in other words, the non-flyers, the non-swimmers of Madagascar, are found absolutely nowhere else in the world. And in the early 1990s, I was casting about for another project, and this one really intrigued me. I didn't think it would go anywhere, but it has occupied the rest of my career. But the fundamental question was, how did those really weird, highly endemic animals and plants get to Madagascar? How did they get there? When did they get there? And from where did they come? And in 1993, when I began this project, this was touted to be the greatest unsolved mystery of natural history. And why is it such an unsolved mystery? It has a lot to do with the fossil record. So if we look at the Cenozoic era over here, and realize that it goes from the present back to 66 million years ago, we see that the fossil record is virtually empty in Madagascar. In fact, it only goes back about 80,000 years for all of these groups of living vertebrate animals. The reason for this is, there are multiple reasons, but the primary one is that non-marine rocks of Cenozoic age are largely missing from Madagascar, which therefore makes it unlikely to find Cenozoic terrestrial vertebrates. So what's the next best thing? The next best thing is the late Cretaceous. So now we're back into the Mesozoic era, the so-called age of dinosaurs, and that extends from 66 to 100 million years ago. As a mammalian paleontologist, I was most interested in finding early mammals, hoping perhaps to find proto-lemurs or proto-tenrecs. But the prospect of finding late Cretaceous mammals on Madagascar was realistically an incredible long shot. And in 1993, if we look at the record of fossil mammals from the late Cretaceous, and realizing that the late Cretaceous is a big long span of time, 34 million years, on the southern land masses, which used to be all combined into one supercontinent known as Gondwana, we see that there are only two red dots here. One of them is in Argentina, and there were known in 1993 some isolated teeth and a couple of fragmentary jaws. And over here in India, just a few isolated teeth. So what were the chances that we would take this long shot and find late Cretaceous mammals in Madagascar? Pretty slim, to be honest. But we had a lead. And the lead was a paper by the most famous French paleontologist at the time, Charles Desperret. He had published a paper in 1896 in which he described some isolated and fragmentary bones and teeth of dinosaurs and crocodiles of late Cretaceous age. And so this was the lead we needed. And of course, we wanted to know how Dr. Desperret had found these teeth. And it all goes back to France's invasion of Madagascar in 1895. So like many of these colonizing armies from Europe, expanding out into Africa, they were there to make Madagascar a colony. But they had another motive, and that was to find objects of natural history. And whether it was, again, insects, spiders, snails, mammals, birds, whatever, they wanted to document the natural history of Madagascar. And one soldier, Company Sergeant Major Landillon, was commissioned to find bones and teeth. In other words, fossils or even rocks, and send them back to Madagascar. And very soon after landing in northwestern Madagascar, he had success. He found isolated bones and teeth of dinosaurs and crocodiles. These are a couple of the teeth he found. They belong to a theropod or a meat-eating dinosaur, and he sent them to Charles Desparet, who then described them in that paper in 1896. Landillon had found those fossils, and it was near the village of Berif. And so with that knowledge and with a little bit of seed money from the National Science Foundation, I encouraged a couple of colleagues and got 3 graduate students to join me on this expedition, this long shot expedition to Madagascar, being incredibly ignorant about a lot of Madagascar. So I didn't know it was, I knew it was a developing country, but I didn't know how poor it was. And so when we arrived in Antananarivo, it wasn't a matter of going to the Hertz rent-a-car desk and finding some vehicles. In fact, it took us about a week to find 3 vehicles. This is one of them. None of them were younger than 30 years old. One of them had already been converted into a chicken coop. But when they found out that we had a little bit of money, they cleaned it up, put in some seats, put on some tires, tuned up the engine, and away we went on this trek to Berif. And that trip took us about 2.5 days with very poor roads and vehicle breakdowns and so on and so forth. We arrived in the middle of the night and we pitched our tents and woke up in the morning and saw some rock outcrop, some exposed rock, maybe 1/4 mile away. We forgot about being tired. We forgot about being hungry for breakfast. We just picked up our rock hammers and other collecting equipment, ran over to this site, and this is it. This is the site that we ran over to. And within 20 minutes, one of the students, Chris Wall, pictured right here, said, "Dave, I think I have a mammal tooth." I, of course, didn't believe her one bit. But I went over and looked at it, and sure enough, it was a mammal tooth. She found it where this red star is, and this is the tooth. And it was clearly a mammal tooth. And so within 20 minutes of starting our expedition, we had done the unthinkable, found mammals in the late Cretaceous of Madagascar. This was one of those magical moments of discovery. We were all jumping up and down, hugging each other. I was screaming in French, and I don't even speak French. So it was really one of those magical moments of discovery. Then we spent another 6 weeks there. You can probably guess how many more mammal teeth or other mammal specimens we found. Not a single one. Instead, however, we found abundant fossil bones, fossil teeth, partly articulated skeletons of almost everything else except mammals. So from fishes to frogs, to turtles, lizards, snakes, crocodiles, dinosaurs, you name it. We found a ton of stuff. And that is what initiated the long-term Majunga Basin project. So what is the Majunga Basin? It is this sedimentary basin in northwestern Madagascar where the French army arrived right there before they trekked down to Antananarivo. So it's in this sedimentary geological basin in which we've been working for a very long time. We've now launched 13 expeditions. The most recent one was in 2015. This is, Alyssa, how are we doing in terms of slide progression? Okay, good, thanks. So this is the field area. It doesn't look that well exposed. It's not like the South Dakota Badlands, but anybody that has ever come there with experience in paleontology says it's the most fossiliferous area they've ever seen. There are bones and teeth oozing out of these rock outcrops everywhere. This is one of our field crews when I was still at Stony Brook University. One thing to point out here is that we have engaged the help of Malagasy students and faculty members from the University of Antananarivo. We try to support the local economy as well by hiring local people to help us in a number of different ways. So this is one of our early field crews, 1998. This is the most recent one. So you can see that we've kind of expanded operations. We have now a field station, a research station up here, which makes life much easier. And down in front here, this is the hall from, or part of the hall from 2015. And we've just had incredibly good luck, good fortune in finding complete or nearly complete skulls and skeletons of a whole array of fossil vertebrates from the late Cretaceous. This is just one example. This is a skeleton of the apex predator, Majungasaurus, that was found. We now have this complete skeleton, and we actually have 5 or 6 other skeletons of this particular dinosaur. We also have complete or nearly complete skeletons of other theropod dinosaurs. Again, here is Majungasaurus down here, but we also have Mexicasaurus, Rahonavis, and 2 kinds of sauropod dinosaurs, this one being the better known, Rapetusaurus. We have 6 different kinds of crocodiles. 4 of them have been described, 2 of them are in the process of being described. But again, complete or nearly complete skeletons of these animals. So incredible richness of fossils. So whereas this was the fossil record before we started our project in the Majunga Basin, now we can claim success that we have mammals, birds, crocodiles, snakes, everything, and as well as dinosaurs included. And we now have almost 50 species, and many of those are represented by skulls and skeletons. And these are various artists' interpretations of what some of these animals might have looked like. The bottom line, though, being that we have about 20,000 specimens, and they're now housed here in the Denver Museum of Nature and Science. So incredible richness with multiple skulls and skeletons. It's all a good news story if you're not working on mammals. We have only 12 specimens of mammals over those 27 years of collecting. And that basically, some basic arithmetic means that for every 1 mammal specimen, there are about 1,667 specimens of other vertebrate animals. And so of those 12 specimens, this was 1 found in the first 20 minutes. And these are 9 others. And you can see they are nothing to write home about. They are fragmentary teeth. Here's a fragmentary bone. They're clearly mammalian. They're important, but they are just fragmentary teeth. And this was a situation until 2010, when the current curator of dinosaurs here at the Denver Museum of Nature and Sciences, Joe Sertich, discovered or actually packaged up the plaster jacket here. And when we scanned it back at Stony Brook, it was filled with fish bones, but in one corner was a cranium, part of a skull of a mammal. And this is it. This is an extraordinary discovery, an extraordinary specimen. And we were able to quickly recognize that it belonged to a very poorly known group of early mammals known as gondwanatherians. In other words, the mammals that were found only on Gondwana. So recognizing that it was important, we gave it the full court press. We had access to technology in the form of micro-CT scanning. This is a new technique that has kind of revolutionized paleontology and that allows us to really study in depth the internal structures of some fossils, particularly crania. So here again is the cranium, and after about 5,000 hours of work of digitally identifying pixel by pixel which bone was which and which suture was which, we have a very good idea of the basic skull morphology of this particular animal. And because we can see inside with micro-CT scanning, we can also understand some internal anatomy. So we were able to reconstruct the brain, which is shown here in blue, and recognize that it had huge olfactory bulbs. And in the inner ear, we could identify the organs of balance, and the cochlea, the organ of hearing. So we could really begin to breathe life into these animals and begin to understand their paleobiology. And this was big stuff for us, and we also described it in the journal Nature back in 2014. However, we had discovered this skeleton that we just described last week of Adalatherium way back in 1999. So it had a much longer history of discovery. It was actually discovered by this Malagasy graduate student, Augustin Ribéry-Son. And Augustin found this specimen right where this Malagasy woman, one of our co-authors, Lydia Rahantarasua, is sitting. And Augustin recognized some crocodile bones, thought it was part of a skeleton, and it was. And so he took out this big plaster jacket along with another colleague. And it just so happened that that year, that very year, 1999, we were being visited by a photographer, Maria Stenzel from the National Geographic Society. And by pure coincidence, she took a picture of this particular plaster jacket being carried out. This is the plaster jacket that contained the bones of the skeleton of Adalatherium, so purely by chance. Since this specimen was thought to contain only a crocodile, we brought it back to Stony Brook University, and it sat in storage for almost 3 years. And after 3 years, we opened up the plaster jacket, and I recognized immediately that below this smattering of crocodile bones was something different. In fact, my technician had exposed the elbow joint of what was clearly that of a mammal. So that was pretty exciting. We ran down to the vet services and got a portable X-ray unit, X-rayed it, and realized that not only was there an elbow joint, which is right here, but there was a whole skeleton. This was an unbelievable discovery. I literally didn't sleep for 2 days. I had 2 sons, as Gabby said at the time, both of them soccer players. And so to provide some perspective on the significance of discovery, I said that it was better than winning the World Cup. It was truly a phenomenal discovery. And just to give you a little bit of orientation, here's the skull. Here are the 2 forelimbs. The backbone goes along here. The tail was curled around underneath it. Here you see the pelvis, and here you see both hind limbs. And so this was prepared. The rock prepared a way so that we could expose the bones over the course of the next 6 months. And it is truly a phenomenal specimen in terms of its completeness and its preservation. I'll talk about that somewhat later. And we developed a method where we could prepare the one side and flip it over and see the other side. So now you're seeing it in reverse. You're seeing the other side of the skeleton. And the preservation is so exquisite that you can see little tiny bones here. These are called sesamoids, and they're on the bottom of the feet. And they're absolutely tiny. We get the very terminal vertebra on the tail. And we also get these things sweeping up towards the sternum or the breastbone. These are costal cartilages. So not only is bone preserved, cartilage is preserved, and this is unprecedented. And this has been reconstructed. You can see in this skeleton that there are some parts that are not well preserved. The back of the skull is not well preserved. The sacrum is preserved, is not well preserved, but almost everything else is. And this has now been reconstructed thanks to tree bowl paleontology nearby here in Woodland Park. And they've reconstructed this skeleton to look like this. They've done an amazing job. And we also had a fleshed out reconstruction done by Siberian artist Andrei Atuchin. And we love this reconstruction. Everybody says it looks like a badger, and there's a reason why we think it might have looked a little bit like a badger. So to summarize the rest of the science part of this talk, I've kind of boiled down why this discovery is important. And I've come up with 5 reasons. I think there's many more, but I'm a little biased in that regard. But I'll hit the first top 5. First of all, it's the most complete and best preserved skeleton of a Mesozoic mammal from Gondwana. So let me unpack that a little bit to give you a sense of scale of both time and space. What do I mean by Mesozoic and Gondwana? This is the Mesozoic era. It lasted from 252 million years ago to 66 million years ago. So this whole span was about 186 million years long. Mammals originated back here and were present for about 160 million of these years. Dinosaurs actually originated pretty much the same time. So whereas the Mesozoic era is known as the age of dinosaurs and the Cenozoic era as the age of mammals, in fact, mammals, 2/3 of their history was during the age of dinosaurs. So they kind of get the short end in that name of this being the age of dinosaurs. But our skeleton is up here, pretty close to the boundary between the Mesozoic and the Cenozoic eras. And what do I mean by Gondwana? All of the land masses were once all together in a supercontinent known as Pangaea. That divided into two smaller supercontinents of Laurasia up here, consisting of North America, Europe, and Asia. And then the southern land masses consisted of South America, Africa, Antarctica, Australia, the Indian subcontinent, and Madagascar. And they comprised what was Gondwana. So again, a sense of size and scale. This is the best skeleton of a fossil mammal from the entire Mesozoic of the southern hemisphere. Secondly, it's the most complete specimen of a gondwanatherian mammal. So I mentioned before the gondwanatherians were a really quite poorly known group. They were first described only in 1986, so fairly recent description for such a major group of mammals. And now we know that they were distributed pretty broadly across Gondwana, the southern hemisphere, even here in the Antarctic Peninsula. But most of these taxa, the vast majority of these taxa, are represented by just isolated teeth and fragmentary bones, with the exception of the two specimens that I've already mentioned, the skull or the cranium of Vintna and this exquisite skeleton of Adalatherium. The other thing to note here is the time scale. So this basically shows that gondwanatherians were around for about 50 million years, and they ultimately went extinct about 45 million years ago. But now with the material of Vintna and Adalatherium, we know much more. In fact, Vintna was the key to understanding what Adalatherium was and to recognizing that it was a gondwanatherian mammal. One of the reasons it took us so long to describe this animal is that we didn't have a clue what it was. It was the crazy beast in that sense. And we didn't know that for a very long time until Vintna was discovered. And Vintna, again, was the key because the snout regions of Vintna and Adalatherium are indicative of close relationship and what allowed us to identify Adalatherium as a gondwanatherian mammal. The third reason why this discovery is important is that it's the best evidence yet among Mesozoic mammals for island evolution. Animals that evolve on islands do so with different food resources, different competitors, different predators, different parasites, different everything. So they evolve adaptations that are different than those that we see on the mainland. And Adalatherium exhibits an astounding array of not just unusual, but in some cases unique adaptations. So if we look at the dentition, and I won't go into too much detail here, but you'll have to take it from me that this dentition is unlike that of any other mammal, living or extinct. It's as if it's from outer space. For instance, here we have incisor, and those are pretty much like rodent incisors. They're ever growing, and they have restricted enamel on one side, but Adalatherium has two of those, not just one. And then once we get back here into the back teeth, again, it is these premolars and molars are built on a plan that is unlike that of any other known mammal. The skull, again, unfortunately, we don't have the back part of the skull, but the front part of the skull shows plenty of weirdness that is unknown in any other mammal. So again, we had CT technology, so we could really identify which bones were which and really drill down on details of the anatomy of this animal. And this is a very busy slide, but this is a top view, this is a front view, and this is a side view. I only want to point out a couple of things here. One is that the bones, the relationships of the bones are very different from any known mammal. It has this really peculiar hole on the top of its snout. This kind of hole that we called an intranasal vacuity is unknown in any mammal. We frankly have no idea what it was used for. And then there are a number of other holes, and these holes are seen in other animals, but not the plethora that we see in Adalatherium. And these kinds of holes we know from living mammals are used to transmit nerves and blood vessels to the front of the snout. And so this gives us an indication that the snout of this animal, the snout of Adalatherium, was very sensitive and probably had a rich supply of whiskers or vibrissae. And then it doesn't stop there. Once we get into the skeleton behind the head, and these are CT reconstructions in side view and here in top view, we see a number of really odd things. It's got a very long back with more vertebrae than in any known Mesozoic mammal. It's got a really peculiar curved shin here, the tibia. And then when you look at the limbs and look at how different they are, it's as if the front end didn't know what the back end was doing. The front end has typical mammalian forelimbs. They're kind of underneath the body. The back limbs are all splayed out, and that's more like in a reptile, like a crocodile or a lizard. So if it was the only bizarre animal on Madagascar, we wouldn't have a strong argument for saying that its weird adaptations were a result of evolving on an island for 20 million years. But we see these kinds of bizarre adaptations in almost all of the vertebrate animals that we have found. And I'm going to give you just 3 examples. So here is a frog that we discovered. It's huge. It's arguably the heaviest frog that ever lived. It's unusual in having armor, not only on its skull, but here on the back. No frog has armor on its back like that. And its smaller living relatives in South America today are sit-and-wait ambush predators. And so some colleagues of ours did a study to examine bite force in this animal that we ended up Beelzebufo, which loosely translated means frog from hell. But when they examined the bite force in this, they thought it was the equivalent to that in medium to large size mammalian carnivores. And in fact, this is some artwork from a National Geographic magazine back in 2009. And this artist portrayed Beelzebufo eating hatchling Machikosaurus or dinosaurs. So this is a pretty cool concept, in my opinion, frogs eating dinosaurs. And when we look at the crocodiles, again, a lot of them have their own peculiar adaptations, but this is the weirdest of them all. Any good card-carrying crocodile has got a narrow snout with conical teeth for capturing prey. This animal, Simosuchus, instead, has a very pug-nosed face. Here you're looking at it straight on, and teeth that are not conical. Instead, they're palmate, they're leaf-shaped. And these kinds of teeth are found in lizards today that eat vegetation. So we, in fact, think that we have an herbivorous crocodile, and it doesn't get much weirder than that. And then we also have a small theropod dinosaur that has buck teeth, teeth that point pretty much straight forward. Again, a very unusual adaptation. So all of this kind of reminds me of a declaration made by one of the first natural historians to encounter Madagascar, the Frenchman Philibert Commerson. He concluded that Madagascar is the naturalist's promised land. There you meet bizarre and marvelous forms at every step. I think we can now conclude that that statement also pertains way back in time to the late Cretaceous vertebrate fauna of Madagascar as well. Fourthly, Adalatherium was one of the largest Mesozoic mammals from Gondwana. And to give the perspective on that, mammals that lived during the age of dinosaurs, most of them were small. Most of them were on average mouse-sized. And if we look at the size of an average house mouse here compared to Adalatherium, Adalatherium was a giant. And it was actually about 100 times larger than an average house mouse. And this is also potentially consistent with the hypothesis that Adalatherium acquired unusual or even unique features, in this case large size, by evolving on an island, because it's quite well known that mammals that evolve on islands oftentimes exhibit either dwarfism or gigantism. Finally, the fifth reason why I think Adalatherium is important is that it was not ancestral to any modern day Madagascar mammal. And in fact, none of the mammals that we found are ancestral to anything that lives on Madagascar today. And to put this into perspective and to allude back to what Gabby was speaking about, at the end of the Cretaceous, there was an asteroid impact. And it, coupled with some volcanism in India, signaled the end of the Cretaceous. And at that time, 75 to 80% of life on Earth ceased to exist. And this is a fundamental part of work being done in the Department of Earth Sciences at the Denver Museum of Nature and Sciences by my good colleagues, Ian Miller and Tyler Leeson. And this is part of the Colorado Springs project that Gabby mentioned earlier. And a little less than 6 months ago, they published an important paper in Science that documented what happened right after this cataclysm at the end of the Cretaceous. And they really drilled down on what happened to mammals and how they diversified. And the interesting thing is that the story may be slightly different for Madagascar. It's undoubtedly the case that life on Madagascar was also decimated. But in North America, for instance, there were some mammals, even though they were decimated, they weren't decimated completely. And some of them snuck through the Cretaceous tertiary boundary and diversified. And it may be a slightly different story in Madagascar because we don't have this record in here, but we do have the record now down here, and none of these taxa are potential ancestors to anything that lives on Madagascar today. So what does that mean? Madagascar was already an island. It had been an island for about 20 million years at the time that we had discovered all of these fossil vertebrates. And today we know, for instance, for mammals, there are only 4 groups of extant terrestrial mammals on Madagascar. There's lemurs, the tenrecs, a peculiar group of rodents, and a peculiar group of carnivorans. And clearly gondwanatherians or anything else we found on Madagascar did not give rise to them, but Madagascar was already an island. So how did these ancestors get to Madagascar? We don't have any record of them in the end of the Cretaceous. Madagascar was already an island at that time. They must have rafted there. I know this is a cartoon and it looks a little bit goofy, but there's molecular evidence to support the hypothesis that they got to Madagascar by rafting across on huge rafts of vegetation, not these little cute rafts here, but huge rafts of vegetation that are ocean liner sized, with standing trees and fruiting bodies that made their way over to Madagascar at some time during the Cenozoic and established founding populations. So I'd like to conclude by hearkening back to Commerson's statement about finding bizarre and marvelous forms at every step. I've been encouraged to show a few additional slides to let you know about something else that we found on Madagascar that is not bizarre, but it's certainly marvelous, and that is children. We found children at every step, and in many ways, you could say that they found us because they followed us everywhere. And To put that in some perspective, Madagascar is quite densely populated, has over 27 million people. These are some of the most abandoned and forgotten people on the planet. And again, Madagascar is one of the very poorest countries in the world. And in these remote areas where we work, this is a typical Malagasy house, maybe 10 by 12 feet in dimensions, straw walls, straw roofs, mud floors, or dirt floors, I should say. And the other context is that the average Malagasy woman has 6 children. So imagine a family of 8 living in a 10 by 12 foot grass house. And these are some of the children. The children are, to be honest, some of the happiest children I've met. But on the other hand, on the polar opposite of that, they're sick and dying. So to make a long story short, in 1996, I convened a meeting of the village elders and chiefs because the villagers had been very kind to us in many ways, and it helped us in many ways. And we wanted to find ways to give back to them. So I convened this meeting and I asked them, I said, basically, you've been wonderful to us. What can we do to help you in return? And somewhat they surprised me because these children that had been following us around all over the place, we realized were following us around every day of the week. In other words, they weren't in school. They were not getting an education. And sure enough, the number one priority of the village elders was an education for their children, because they knew that that would be the only way out of poverty. And this is in a village where nobody could read and write, neither children nor adults. And so the obvious next question was, well, education, how do we do that? And they said, well, you could hire a teacher. And that seemed like a tall ask until I asked how much that would cost. And they said $500 a year. That was a no-brainer. We went back to camp and we pooled some money and we started a school. And that school started underneath a mango tree with a blackboard, and we had initiated a school. And one thing led to another. And a couple of years later, I started this fund that Gabby mentioned, the Madagascar ANKIZY Fund, ANKIZY meaning children in the Malagasy language. And its sole purpose is for the education and healthcare of children living in these remote areas. And at the time, one of my sons was in the 8th grade. He was in an art class. I made a challenge to the art class to come up with a logo. This is the logo, and it basically unites what we do in terms of building schools and what we do in terms of paleontology by using the colors of the Malagasy flag and uniting them with a rainbow. It's a beautiful logo. The only downside is that it looks like our dinosaur is about to eat these little children. Other than that, it works pretty well. So again, to cut long stories short, we've had some success. We've built 6 schools. 5 of them are primary schools. 1 of them is a secondary school. They are bursting at the seams. We had to renovate 2 of them and expand them. Now in the initial village up here, some of these children pictured in 2001 have gone on to high school where we support them in the city, and some have even gone through university. So now in this village of Bereaved, where nobody could read and write, adults or children, there are children who have advanced through university. This is a shot of some of the classrooms. The children are incredibly eager to learn. I love this photo because this little girl, her name was Narendra. I used to visit her parents and usually had something for the children. This day I had some chalk in my pocket and gave it to her, and she said, stop, I want to show you what I learned in the school. And she started to write out sentences in French and do some arithmetic. And in the most recent visit, I encountered her again. This is Narendra, now a grown young woman with 2 young children. This is her father. Narendra is an accountant, and she's able to support not just her immediate family, but her extended family. And the other mission was healthcare. And the children in Madagascar are malnourished. It's very sad for us because we get to know these children very well. We come back the next year and some of them are gone because they died of easily treatable diseases, diarrheal diseases, respiratory infections, malaria. Those are the biggest killers. And because I was at Stony Brook University and I was teaching human gross anatomy to dental and medical students, I arranged for missions to go to Madagascar. Dental and medical students yearn for the opportunity to go on these sorts of missions, and they've been very highly successful. So in addition to healthcare and education, we've done some other things in healthcare, like distributed mosquito nets. We've instituted a novel method for purifying water with UV radiation. And it's been, I think, a success, but I think it's something that anybody who encountered the poverty there would do. I refer to it as science with a social conscience. So I'd like to end there with acknowledgments to the field crews, to collaborators, to the government, to facilitators of our expeditions, the National Science Foundation and the National Geographic Society for research funding, as well as my employers, Stony Brook University and the Denver Museum of Nature and Science, for putting up with me. But I can't close without doing a little bit of museum promotion. Even though our doors are currently closed, we're working hard to provide ways in which to engage you and your families to learn about nature and science. And so we've got many of our programs, many of our workshops and resources are now available online. And coming soon, as indicated by this slide, we hope that there will be an exhibit on Adalatherium and other bizarre animals from the late Cretaceous of Madagascar. And this will happen sometime after the museum opens. You will see there the two things that I have over my right shoulder here. You will also see videos of Adalatherium and other animals. These are put together in our digital research lab by our technician, Lindsay Dugan. She has volunteers and interns working with her to do these kinds of videos, and there'll be a number of other videos available in this new exhibit. So with that, I'd like to thank you, and I will take some questions, but I will, once we switch to my screen, Alyssa, I'd love to hold up. What do I have to do that? Stop share? Yeah, there we go. Can people see me now?
Yes, they can. You can go ahead and share here.
Because I wanted to promote this, if you can see it. This is a skeleton, again, done by tree bowl paleontology, which will be on display. And then this is a reconstruction of Adalatherium. And this was done from the artwork done by Andrea Tuchin. But this is a 3D print. And this is done by computer-aided technologies here in Denver, and then printed by Stratasys. And so this is very high-end 3D printing that shows not just the full color, but every detail of the hair. It's very, very high-end technology to get this done. So these will be on display. Please come look at them when the exhibit opens. And with that, I'll close and take questions.
Thank you so much. That was a fantastic presentation. And I just want to let you know, when you go back and look at all of the comments, you have an incredible following of very smart people asking incredible questions and thanking you for all of your work. So thank you for doing this presentation tonight. And we have about 15 minutes for questions. So I'm going to just fire away if that works for you.
Absolutely.
All right. So to go all the way back to the beginning of your presentation, when you found the skeleton, why was it so obviously mammalian to you and your team?
So a number of features in the skeleton, but I'll key here on the teeth. Mammalian teeth are particularly complex relative to reptilian teeth on average, or amphibian teeth, and there are quite a few characteristics of mammalian teeth. I mean, they have a complex morphology. They have wasting at the bottom of the crown, and they've got multiple roots, and this clearly had those. And we actually, as mammalian paleontologists, are restricted somewhat in what we can do, because the fossil record is comprised primarily of teeth, and that's for the simple reason that enamel is the hardest and densest tissue in the body and has the best chance of being preserved. But it was clearly a mammal from not just its teeth, but the skull and the skeleton behind the head as well.
Great. And then to relate to that question, what factors lead to the disparity in abundance between mammals and all of the other vertebrates at the sites that you checked?
Yeah, I wish I knew. Because mammals in North America, for instance, are I wouldn't say easy to find. They're all small, but they're found in some abundance. And we have found many of them in North America and in the Eurasian continents in general by doing things like screen washing. We know the mammals are small. We know the teeth should preserve well, so we do screen washing or even dry screening to find the smallest fraction. We've done a fair bit of that in Madagascar, and it hasn't helped a lot. Another perspective there is that the Southern Hemisphere is really poorly known relative to the Northern Hemisphere in terms of knowledge of these early animals. And the mammalian record from the Mesozoic of the Northern Hemisphere is an order of magnitude better than that from the Southern Hemisphere. And that has to do to probably 3 or 4 factors. One of them being that most of the Southern Hemisphere is close to the equator, and therefore you're dealing with tropical rainforests. And it's hard to find exposures, rock exposures in tropical rainforest. In some areas, just rocks of the appropriate age aren't preserved. But probably the biggest factor is that it remains relatively unexplored. There is still so much to do. And I would love it if this would encourage other people to start exploring in the Southern Hemisphere for Mesozoic mammals.
Great, thank you. Do you have any explanation for the missing Cenozoic fossils on Madagascar?
Yeah, so it almost is certainly the case that it is such a poor record because rocks of the right age are not preserved. And without going into too much detail, these basins that I was referring to, they're off to the west. And when the central part of Madagascar was being uplifted, sediments from those high areas were shed down into the basins. And they basically filled up during the Mesozoic. And so anything that was washed out from the highlands later than that got washed out to sea. And as a result, Cenozoic deposits were never laid down in what is now Madagascar.
Very fascinating. How do you think your mammal's teeth relate to what you think its diet was and what the environment was like when that creature was running around?
I didn't hear all of that, but I think it relates to what was the paleo environment at the time. And we know a lot about that thanks to our geologist, Ray Rogers. And we know, for instance, that it was a semi-arid climate with long dry seasons and short rainy seasons. And during those rainy seasons, there were sediments washed out from the highlands in debris flows. And these debris flows basically covered up everything that was in the floodplain that might have died months ago or the day before, or was even buried in the debris flow. And because this skeleton that we have is so well preserved, we think it had died shortly before the debris flow, or was even killed by the debris flow. And that's indicated by the fact that all the bones are still pretty much in articulation. We also don't have sediment that went inside of the bones. You would expect that if the bones had been laying out with all the little foramina in them, the sediment, really fine sediment, would have washed inside of those bones. But we don't see that at all. And there's tons of evidence that Ray has elucidated to document that the environment was a pretty hostile one with very harsh, dry climates for most of the year.
Awesome, thank you. We have a few questions coming in our webinar. You mentioned that there was a reason you think this animal might have resembled a badger, and why do you think that?
Well, we still have a lot to do with studying this specimen. We are in the process of putting together a 250-page monograph on this animal, but even that is restricted to the anatomy and the relationships of Adalatherium and other gondwanatherians. We still have much to do in terms of looking at dental function and potential diet. We do feel that it was probably an herbivorous mammal, but also with the skeleton behind the head, we're trying to figure that out. But our preliminary analysis suggests that Adalatherium was capable of running and walking like a badger, but also of digging potentially like a badger. And even though we don't have any evidence for the coloration or the patterning, it's that idea that this thing may have been a digging animal, one that dug burrows, that we gave it kind of a badger coloration. And so you might also ask, well, why would it dig burrows? Animals dig burrows for a lot of reasons, but this was a pretty hostile environment for a tasty, juicy 7-pound Adalatherium, because there were large predatory dinosaurs. There were several species of crocodiles, and we have a huge snake, the largest Mesozoic snake known from anywhere in these deposits as well. So not a very friendly environment for a Adalatherium.
Fascinating, thank you. We have some questions from some sci-fi fans. Do you use any ground penetrating radar or technology to look for fossils before you dig for fossils?
We don't, and I know very little about that technique. I know that it has been tried and just hasn't been very successful. Just like for our CT technology, you need really good density contrast. And sometimes the rock and the bone has pretty much the same density. So the further down you go, the more difficult that contrast would be.
Great. Two more questions here. Were the bones that you found along with the crazy beast actually alligator bones, or just more bones, more copies of that crazy beast?
Well, I love the question because it gives me an opportunity to explain that in addition to those not so great crocodile bones on top, they just weren't very special, and that's why we didn't open that plaster jacket. But once the plaster jacket was opened and the skeleton of the mammal exposed, about 5 centimeters, 2 inches below the mammal skeleton was another skeleton, and it was of a hatchling crocodile. So it was maybe 5 inches in diameter, and it was perfectly curled up. Some of its bones weren't even ossified. They hadn't calcified yet. So this is something that our curator of dinosaurs, Joe Sertich, is actively doing research on, along with a Malagasy graduate student.
Great. And then one more question. Does Madagascar have a natural history museum? And how do you share your knowledge of these findings with the people of Madagascar?
So that's an interesting question. Again, Madagascar is a very, very, very poor country. And we have encouraged the building of infrastructure in Madagascar through Stony Brook University. We've actually been able to build some collections facility in which the fossils can be stored, because our agreement with the Malagasy government is that half of the fossils that we find will be ultimately sent back there after they've been prepared and studied. And the Denver Museum of Nature and Science has actually donated some perfectly serviceable specimen cabinets to Madagascar as well. As far as a public natural history museum, there is not one. There are small little museums in various cities, but there's not a major natural history museum in Madagascar.
That's great. Thank you so much. And we do have some questions coming in. You guys can all access this recording on the DMNS Facebook page. We will also post a recording of this webinar on dmns.org/learn later on in the week. And I would like to invite Gabby back to give us our final remarks. Thank you once again.
Thank you, Alyssa. And Dave, thank you for sharing that amazing story. I think everybody absolutely loved it. Just seeing the chats, wait until you see all the comments. You're gonna be blown away. So I just wanna say thank you again to all of you that participated and that have participated in all of our virtual programming. I said it before, it means so much to us, the staff of the museum, that you remember, that you support us, and that you join us in these events. So thank you, and please remember, as soon as we reopen, please come and see our exhibit that we will have for this new discovery. So have a wonderful evening. Thank you.